All right, hello, welcome everyone. Hope you're all doing well. Hope you all had a great weekend. Let's start by just kind of going over some announcements and reminders of things. I'm sure you're all interested in hearing an update about the exam that you took last week. The grading's been going very well. I expect the grades will be back tomorrow, so I'm in the time of loose ends phase of grading where I just have to go back and find a few things just to, like I said, have a few loose ends. Should hopefully not take me too long, but I think tomorrow's a reasonable estimate for when you'll be getting those grades back. It's possible it might leak over into Wednesday, but I really don't think so. I think tomorrow's gonna be the day. As far as the rest of the class goes, I just want to make you aware that the end is actually kind of sneaking up on us pretty fast. So we have only 2 more new units of material to cover. Today is one of them. Next week is the last new material that we are going to cover in this class. So with that in mind, just to keep an eye out on the calendar. We've obviously got Thanksgiving break coming up the week after that, so there's no class that week. I just can't really use that partial day very effectively. I probably will have some additional office hours on that day though to make up for the lack of class if you want to come in and get some help on homework assignments and stuff like that. But really you're looking at the three remaining assignments, the 2 remaining studios, and then of course we have exam 3 coming up, and the final exam if you choose to take the final exam. So that's really all that's left for this class. Want to make sure that you're aware of where we're at, how much left we have to go. Actually, after we come back from Thanksgiving, that end of class is going to be right on top of us because there's really only 1 week of class left after we get back from Thanksgiving. So it's going to be the finish line's right there. So just want to make sure everybody's aware of that. Also want to take a moment to say that I fully understand that this is a stressful part of the semester. It's stressful for me too. I have to write the exams and grade the exams and can turn around pretty quickly so that you all can decide whether or not to take the final. And then I have to grade the final exam, which I usually do by myself because all my TAs have finals. So, it's definitely a busy, stressful time of year for all of us. I just want you to know that, remind you that you have options to kind of ease the pressure. Please use your late coupons if you need to. That's what they're for. You need a few extra days on assignment. That's what they're for. If it buys you a little bit extra time, they don't do you any good. If you have late coupons at the end of the semester, they are worth nothing. Absolutely nothing. So use them if you want to, if you need to. If you're out of late coupons, I don't like deadlines to be the reason why people can't turn stuff in. Shoot me an email. I will happily give you some additional late coupons if that'll help you bridge the gap, make it through the last few weeks of the semester. I know it's stressful. I know it's hard. Please make sure you're taking care of yourselves. You're getting sleep, getting food, stuff like that. So, and let me know what I can do to help you out. I know that a lot of people probably still have their studio drops left and are maybe looking forward to using those studio drops to not have to come to the last couple studios. I would encourage you to consider that carefully. I truly believe that doing the studios is useful for learning the material and ultimately completing the assignment. But of course, you're adults. You get to make your choices, right? I can't tell you what to do. I just hope I'll see you in the studios this week and next week. I will be there. So that's it for my update on the state of the course. Does anybody have any questions about what's coming up in the next few weeks, the last few weeks of the semester before we hop into today's materials? Oh, one more thing. Now's also a great time to just kind of check over your grades in the grade book, make sure there's nothing weird in there. Definitely would like to get those resolved sooner rather than later. I promise you, if you ask me to fix a homework assignment grade after the final exam, I'm going to be like, sorry, too late, class is over. So please take a look at that. Please take a look at the stuff on Canvas, make sure everything looks legit. If it doesn't, shoot me an email so we can figure it out sooner rather than later. All right, great. Today, we have a topic that, like we've seen before, is going to build pretty heavily on the topic that we saw last time. So objects are really a big deal, huge deal for us in this class. And today we're going to be talking about objects a lot more, and we're going to be introducing a new concept that builds off of the idea of objects called inheritance. So every example that we look at today is actually going to have 2 pieces of code associated with it. That's just kind of how inheritance works, right? Inheritance, as the name somewhat implies, allows us to take code from one class, right, from one file, and reuse that code or inherit that code in another file, or another class. So the piece of code that we're using as our starting point that we're going to inherit from, that's what we usually call the base class. And then the piece of code or the class that we are going to be reusing the code in, right, that's what we usually call the subclass. You might also hear it referred to as, the base class referred to as the superclass. We're going to talk about a keyword today called super. So super and base kind of mean the same thing. And like many other things, there's a relationship we can use to describe inheritance. So we've described relationships between an object and the instance variables that it contains. What's the relationship that I use to describe a class and the instance variables that it contains? Review from last week. Person, blank, name. Anybody remember? Has a, yeah, has a. So we'd say it's a has a relationship for our instance variables. The methods are things that our objects can do, classes can do. That's our behaviors. Those are the verbs. The methods are the verbs. Inheritance is going to specify a different type of relationship. Inheritance specifies a relationship classified as an is-a relationship. So the thing that is doing the inheriting, right, is a version of the base class. So the way I would say that in our very first example, if I take a look at this person class, you can see a person has a name. And then we've got some methods down here, really just some accessors, right? Some getters and setters for the name. An employee is a person, right? Employees are people. I could also use this same concept for students. Student is a person, right? Professor is a person, right? Lots of different ways that we could take this in, but we're just using employee. And so this is the magic word that we see that indicates inheritance is being used here. The extends keyword quite literally says, go find the person class, and then everything that exists in that person class, I now want to have access to it in this class, in the employee class. So all of the stuff from the base class is going to be inherited into the subclass. What are the two kinds of things that we're going to inherit? What are the two kinds of things I expect to find in classes? Methods, that's one of them. What's the other one? I've already talked about it a little bit. Getters and setters are methods, so technically yes, but that's not the category I was looking for. Instance variables, instance variables. So all of the instance variables from the person class and all of the methods from the person class are automatically accessible here in the employee class. Notice though that I don't have that instance variable, right? I don't say, here's the instance variable called name. It's implied. When I say this here, that automatically says that there is another instance variable here called name that comes from the person class. So think about what that means from the point of view of the, what is this method called again? It's called employee, but it's an example of a word that starts with a C. Constructor, right, constructor, good. So think about what that means in the role of the constructor. The constructor's job is to make sure that all instance variables get set. Every single instance variable that the class has access to gets set. So that means that we have to set not just this instance variable that I see in the employee class, but I also have to make sure that the name instance variable from the person class gets set, because I have inherited this from the person class. It also exists in the employee class because I'm using inheritance here. So the constructor has to set two instance variables, the one that's included directly in the subclass, but then also any instance variables that come from the superclass. The nice thing is that we can actually use the constructor from the superclass to help us with this. So the idea is that the person class has a constructor, right? Here it is. This is the constructor for the person class. I'll use this constructor to set all of the instance variables for the superclass, and then I'll just set all of the other instance variables from the subclass the same way that I normally would set instance variables. So if we look at the way that the constructor for the employee class is set up, you can see that it does take in two values, not just one. It's taking in a value for the name, which is from our base class. It's also taking in a value for the ID, which is right here in our subclass. But for the name, it calls the constructor of the base class. And it does that using a new keyword, our second new keyword of the day, super. So anytime we see that super keyword, we are referring to the base class. In this case, I see super with parentheses immediately after it. That's how we call the constructor of the base class. And we can tell that because this takes in a single value, a string, representing the name. And if we look at the person class, that's exactly what it's expecting for its constructor. So if we think about the role of the constructor, this one takes care of inherited, instance variable, and this one takes care of the one here. So the role of the constructor is still the same, right? We're just using the constructor from the base class to take care of those, and then we handle the other ones ourselves directly. Are there any questions about the constructor that I've shown you here? Any questions? Yes, in the back.
I just have a clarifying question.
Sure.
When we are doing an employee extension persons, for example, we're going to refer to, we can't actually access the instance variables of person, right? So we have to use the constructor variables in order to
I think I might see what you're getting at. Are you saying, like, why don't we just do it like this? Is that kind of what you're asking, or am I barking up?
I guess what I'm more asking is why can't we just say super name instead of super doesn't?
I mean, this is just a variable name if you don't like it. In fact,
the other one, like the actual instance variable, is called name.
yeah, it doesn't matter. This is just these are two separate variables. This one is a parameter to the constructor, and this one is an instance variable, but they're very much two separate variables.
I understand that, but in the student class,
And the employee one?
refer to the name.
Uh-huh.
When we say super the name,
Yep.
is that not referring to the name parameter from the person class?
No, it's referring to this one right here, and I can illustrate that by changing the name of this to be something else. Or to be even more explicit about what's going on here, the person class is expecting any string. I could literally put any string that I want to in here. So if I wanted to, I could do this. This isn't very useful because now everybody's going to have my name, but it literally will take any string. The string that we gave it is this one. So when I construct an employee, I'm saying you have to give me a name and an ID. I'll pass the name to the person constructor, let it do its job, and then take care of the ID here. Does that help clarify what's going on here? I guess another way of saying it is this is a different variable from this. These are not the same. Right? I've connected them up by calling the constructor and passing the value in, but they're two separate parameters to two separate constructors.
Okay, and we're getting that value from the constructor in the class.
Whoever wishes to create a person, has to tell me what this value is. Whoever wishes to create an employee has to tell me what these two values are, right? And then I call the person constructor to take care of the first value, and then deal with the second one myself. It is confusing. You're right to be asking questions. Absolutely. It's an abstract concept. Definitely takes some brain power to put the pieces together. Does this help clarify, though?
Yeah, that's helpful.
Okay, cool. Did I see another question over here? Did I miss a hand? No? We're good? Okay, just want to make sure. So we haven't talked about the methods yet, right? Actually, before we talk about the methods, let's just get a little bit more practice setting up inheritance and talking about constructors. So we've got a little exercise here. This is our base class. Base class is that we have a rectangle. You can see rectangles have length, and rectangles have a width. This is actually, we see an example, we have two constructors here. This is what's called the default constructor, right? So if I don't tell you what size of a rectangle I want, it's just going to Just going to make a 1x1 rectangle, a very small one. Otherwise, I'll use whatever value, tell me how big of a rectangle you want, and I will remember that. And this is a very rudimentary kind of drawing thing that doesn't use standard draw. It actually just draws it on the console using print statements. But let's talk about the square class, because remember the relationship that we talked about. The is of relationship, I mean, that very clearly fits here. Square is a rectangle. We learned that in geometry class all those years ago when we took geometry. Square is a rectangle. So it makes sense to use inheritance here. So if we follow the instructions that are present here as part of this exercise, we need to make this class inherit from the rectangle class. We'll use the extends keyword for that purpose. As soon as we type in extends rectangle, that means that we get all of the values from rectangle, the instance variables as well as the methods from that class. It wants us to add a no argument constructor here. So that means a default constructor. In fact, that's kind of what I've been calling it, so I might actually stick with that terminology. And if we want to, we could actually just use the default constructor from the rectangle class to help us out, because interestingly enough, it happens to make a square. 1x1 is in fact a square. Length is the same as the width. So that's fine here. If you didn't like that, then make a different square. If you want a 2x2 square, okay, whatever. Make a 2x2 square as your default. That doesn't, right? They didn't say what kind of square to make as the default. They just said make a default square. So you can be a little bit creative for that one. Here, though, we need to make another constructor that allows us to create a square of any size. And if you think about it, we really only need one value to do this, because squares have the same length and the same width. Oops, how did I get up there? Int size, right? So we have to set all of the instance variables from both the base class and the subclass. What's interesting is we don't actually have any instance variables in this class. So really all we have to do is set the two instance variables from our base class, the length and the width. And we'll do that by calling the appropriate constructor. So we'll use super. And if I want to use the same value for the length and the width, then nothing is going to stop me from doing that, right? So I can plug in the given size. I'm just passing this value from the square constructor into the constructor for the base class, the rectangle class, that should create a rectangle with equal length and width. And then down here, they actually gave us some stuff we can use to test using the fancy little draw method that they've created. We can see that they first create a rectangle and tell it to draw. Then they create a default square, and then they create a square of size 3. And if we run this, we'll actually be able to see, hopefully, all 3 get printed out. So here's my rectangle, here's my default square, and here's my square of size 3. Notice, though, I want to point this out. This is the first time we've actually seen this. I call this draw method upon the instance. This method is not in this class. Nowhere in this class is there a draw method, right? Where did that method come from? It came from the base class. The rectangle method the rectangle class has a draw method. Because this method exists in the base class and we are using inheritance, right? We can also use this method upon our squares. That is the magic of inheritance. That is why inheritance is so useful. Yes, question? Does the base class always have to be in the same package? I don't believe that it does. I do think it would be a little unusual if it wasn't, though. I mean, the objects that are inheriting do have a relationship, right? They're going to be very closely related to each other. So, I could see if you have a really big project, lots of files, that maybe it would be useful to break them down into different packages. For the simple kinds of stuff that we're working on, we probably won't see that so much. Yeah. Yeah, what's up?
Follow-up question to that. How does the clerks know which person to reference? So it's like person class that we had last time.
Absolutely, yeah. I mean, it definitely is going to look at the package first. And you can refer to things. So let's say the question was, how do I refer to something from a different package? I mean, I have a person class here, and that's the one that it found. That's the closest one, right? That's how it finds it. It's going to look the close first. If it doesn't find it there, or if let's say I want to use this person class, I believe, I haven't done this in a while, but I believe I can just type the name of the package out in front. Will it let me do that? Oh, if it helps if I spell it properly. Nope. Well, I thought it was going to let me refer to the person class here, but it wouldn't let me. I still didn't spell it properly. There we go. Yeah. If you type it in properly, it actually will let you reference a class in a different package. Yeah. Good question. Good question. You won't see this in this class. I can tell you that right now. But in other classes, maybe you will. It's possible. Any other questions before we move on to the next? Yes? How is inheritance different from getters and setters? Well, getters and setters are used to access instance variables. With inheritance, I mean, we're inheriting all of it. I'm getting all of the methods, including the getters and setters. I mean, the draw method that we are inheriting in this last example, right? That's not a getter or setter. That is just a regular old method. It doesn't exist in this class. It does exist in the base class, though. And because we're using inheritance, that allows us to use this method. Consider that if we didn't have inheritance, right, what would this look like? Well, if I wanted to draw squares, I would have to have this method twice, once in the rectangle class and once in the square class. That's redundant. That's two different versions of code that exists when I really don't need two separate versions. It could work for both rectangles and squares. So inheritance allows us to pull not just getters and setters, but all methods, including constructors and getters and setters and everything else too. Yep. Good questions. Anything else? We'll move on. All right. So the next thing that I want to talk to you about has to do more with methods. So this is kind of a contrived example, not a very practical example in my opinion, but it does illustrate the concept. We have a class here called greeter, and this one is, pretty straightforward. It just says hello, or if you pass in a string value, you can see that it'll say hello to that particular person. Notice though that the names of these methods are the same. This one is called greet, and this one is also called greet. This is actually an example of overloading, right? So whenever I have two methods with the same name in the same class, that's called overloading. And that has nothing to do with inheritance, actually. That's a thing you can do whether inheritance is involved or not. That is a pretty common thing to be able to do, actually. You may have seen this on the last homework assignment. Where inheritance comes into play is, let's say that I have another class, a subclass, and I want the greet method here to work differently. So we can see that the greeting in this one is relatively pleasant, whereas the greeting in this one is pretty mean. It says go away, right? The behavior is going to be different. So this method was inherited from the base class. We can actually see that I'm using inheritance here. So I'm extending this base class. I did inherit this method from the base class. However, I decided that I didn't want to use it. I didn't want to use the method as inherited from the base class. So this is actually something a little bit different. This is what's known as overriding. You might sometimes see such methods marked with the override annotation, right? Indicating that this method does exist in the base class, and I do inherit that method, but I'm choosing not to use it. I'm choosing not to use the method that was inherited. I'm choosing to define my own version of that method in this class. And this is useful because it allows us to pick and choose which of the methods we want to use. So when I use inheritance, I inherit all of the methods, every single one. So, chances are that I want to use at least some of them as is. If there's maybe one or two that I don't want to use that I've inherited, I have the ability to override them and provide my own implementation of that particular method. And so if we look here at what happens when we try this out, we can see first we create the regular greeter and tell it to use its greet method. Then we create this mean greeter and tell it to use its greet method. This first one is going to do the nice one. The second one is going to do the mean one because that method has been overridden. So if we run this, we'll actually see. Whoops, I ran the wrong one. Sorry about that. I need to run this one. Okay, so there's a nice green followed by the mean one. However, let me make it absolutely clear that all methods are inherited. So if I want to use the second version of this method by plugging in a name, I'll plug in my name to both of these. Notice that I'm calling this method upon the subclass. This is an instance of the subclass. There is no method in here that matches what I'm calling. I am using the exact same method both times, right? This one uses the method directly since it's defined in the greeter class. This one is using the same method that it is inheriting from the greeter class. It's inheriting from the base class. So because I didn't override this method, right, it'll still use the version that gets inherited, and we'll see the same answer gets printed out both times to prove that fact. So the way we ran it before, right, we could see that I can change the behavior of the method if I want to. This way shows that if I want to just use the method as is, I can just not override it and it'll use the method as is. Any questions about that before we take a look at the next example on our to-do list? Okay. Let's talk about the super keyword some more. We saw the super keyword used with the constructor. That's not the only place that you may see the super keyword come up. The super keyword is, in a general sense, just used to refer to the base class. Period. That's what the super keyword is for. So anytime you see that word super show up, I want your brain to think base class. I'm doing something from the base class. Maybe it's the constructor. We're actually going to see that quite a bit, that it is referring to the constructor. It could also be referring to one of the other methods. It could also be referring to a different method that's not the constructor. And this example is going to try to show you why you might actually want to do that. Let's think about a different way of inheritance where I have a subclass. It's going to take the method from the base class, and that method works, kind of the way that I want it to, but I want to add something to it. I don't want to change it completely and redo it from scratch. I want to use the method that I've inherited, and I want to add something else on top of it, do something else in addition to what my inherited method is going to do. That's a good situation to use the super keyword. So if we take a look here, there's a very, very, very simple method that tries to say, if we grab a food from a person, it's going to say hamburger. But the same method in the student class, we want to have, give us two things, hamburger and taco. I've heard that the food situation on campus is pretty nasty. Actually, I've experienced the food situation on campus not being super great. So I can certainly understand why some of you would want a hamburger and a taco to eat. But notice in this method, we use the super keyword to refer to the get food method from the base class. So we're saying, first, go do all of the stuff from the base class version of this method and stash that in a variable, and then I'm going to tack on this extra thing in this version of the method. So we're able to use everything from the inherited version of the method and do some additional work on top of that. You could also get to this by using the previous concept of overriding, right? I don't like that as much because think about what it would look like if we just did a plain override. We would have to do return hamburger and taco, but there's a redundancy. We can see that doing it this way introduces a redundancy where this is a very trivial bit of code. Imagine if this method was a lot longer and did a lot more stuff, right? Maybe it's 10 lines long instead of just 1 line long. having to redo all of those 10 lines here and then add an additional line or two after that, that's a lot of redundancy. It's a lot of code. I'm back in that same situation where I don't want to be in, where I have two different versions of the same code, basically. So using the super keyword to refer to the original version of the method is the cleaner approach, considered the cleaner approach to this. And so we can see, if we actually want to try this out, I believe there's a main method we can use here, right? We can actually run this and see that, okay, oh, this is actually an interesting little, I guess kind of a tangent perhaps. Notice this is the constructor that I'm using, right? But look at the type over here. Does that feel a little weird? I hope that it kind of does feel a little weird, and if it does, let me try and make it feel a little less weird by reminding you that inheritance describes a relationship. A student is a person. That's what inheritance says. So anywhere that I have person, I can, it could actually be a student. Because a student is a person. Turns out this is actually a very, 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 very important and useful concept when using inheritance. Another good reason to use inheritance that we're going to talk about towards the end of class today, called polymorphism. The idea that I can treat an object either by its subclass or its base class. So I have the ability to treat it as either type. If I have a student, I can treat it as a student, or I can treat it as a person, because a student is a person. So I have the ability to use either type to refer to that object. It's an interesting concept called polymorphism. We'll see that pop up again a little bit later. But to get back to this topic, you can see that if I use the student, I get the second version of the get food. If I switch to person, I'll get the original version from the base class. Whoops, or I'll get an exception because a person only has one parameter, not two parameters. So I need to call the constructor properly. But before I move on, I actually want to run this one through the debugger with you. I'm going to switch it back to how it originally was with the student and show you what happens when we call these methods. So I think it's pretty important to understand the flow through the program. All right, here I am about to call the student constructor. We can actually step into that and see that the first thing that it does is it calls the constructor for the base class. So it's taking these values over here, it's plugging the name into the constructor for the base class. If I step into this, look at where we go, right to the constructor for the base class. It's using it directly. All right, that sets that instance variable. There we go. Once that's done, if we go back, we're back in the constructor for the subclass now. But if I look at this, you can see that the name has been set. The ID hasn't yet been set. That's our next task. So we'll set the ID accordingly. There it goes. And now our object is complete. We set one instance variable with the constructor from the base class and one instance variable directly. If we keep going, our next task is to call this getFood method. And so when we step in, here we are on our first line. You can see that it's actually saying, go run the getFood method from the base class. Go do that first. So if I continue to step in, you see that we pop back up to the base class, and it's going to do the stuff in this method. Once that's over, we get the output back. We do whatever additional stuff we need to do in our subclass to tweak this behavior a little bit, and then we see the final result get printed out. So we actually have the ability to use the stuff from the base class either as is or modify it in different ways. We can use overriding to just ignore that version completely and provide a new implementation from scratch, or we can use the super keyword to use the implementation from the base class and provide some additional work, some additional steps beyond that we want our subclass to be able to do. Any questions? What questions do you have? Yes? Yeah, that's a great question. So the question was, how do we know which version of the method is going to be used Is it going to be the one from the base class or the subclass? The answer is it always looks for the closest one. So if I'm a student, right, and I see a version of that method in the student class, that's the one I'm going to use. If I'm a student and I don't see a version of this method in the student class, then I'm going to go to my base class and I'm going to see if it's there. So we always look at the closest place first, meaning that if I'm using inheritance and the object is the subclass, I will use the version of the method from the subclass if it exists. And if it doesn't exist, then we check the base class. Make sense? I know it's confusing. I know I'm using a lot of abstract terms to describe this very new concept, so happy to re-explain, go over again until you all get it. Not seeing any more hands, so let's try, one more exercise. Here we have a class called customer. Customer has a name and an address, and you can see that we have the ability, to create customer objects. We wish to create a subclass called online customer that inherits from the customer class, and we want to enter a new instance variable for that. So if somebody comes into the store, they don't necessarily have to provide their email address, but if they're buying stuff from me online, I got to know what their email address is. So that's going to be an additional instance variable that we have to account for, right? So let's go ahead and start putting this together. Our instance variables. Email is probably a string. What did I forget to do here? Private, good. All instance variables should be marked private, at least in this class. We're now going to create the constructor for this. Does it want us to do a default constructor or no? I don't think it actually needs to do a default constructor. I think it just needs to do a regular old constructor where we take in a string to represent the email, but we're also going to need to take in values to represent the name and the address, because we're going to have to call the constructor from the base class and pass those values in. So this constructor actually is going to have 3 parameters coming in. All strings, name, address, and email. See if I can fit this a little better on the screen. We're going to use the super keyword that we're going to call the constructor from the base class. That's what's going to take care of the first 2. Oh, I forgot a very important step. What did I forget? It's getting mad at me. It says the constructor object is undefined for 2 string parameters. But wait a second, I don't want to call the constructor for object. I want to call the constructor for customer class. What did I forget to do? I forgot to I forgot to tell it we're using inheritance. I forgot to put in these words here. It doesn't know that I'm using inheritance until I add in this extends keyword. There we go. That will hopefully fix that error. Oh, not online customer, regular customer. Goodness gracious. There we go, finally. Finally I did it properly. All right. Fixed our inheritance here. Called the constructor from the base class to take care of those 2. We just have to worry about the email. So I'll just say this.email is equal to the email that's coming in as our parameter right here. And now this constructor is complete. We are properly setting all 3 instance variables, 2 of them through the base class and 1 of them directly. They now want us to override the toString method. We talked about the toString method, last time not last week, that was the examiner, but 2 weeks ago, I guess it would have been. They want us to override this and add in the email address. But notice that this already does the name and address for us. We don't really want to mess with that part. We want to keep that part as is and just tack on the email address to the end. So really, what we need to do is something like this. If we say public string toString, we need to access the version of toString from the base class. We'll do that using the super keyword. So we'll say super.toString plus, and then we can add our email address on, like so. So instead of having to retype out, name and address, in this method we can just reuse the code that we already have and then tack on the additional information at the end. If we go back to the customer class, they actually have a little way for us to test this. Obviously the first one is just a regular customer, so it's going to not have an email address. This one does have an email address at the end, so we should see that get printed out when we print out the online customer. And there we go. This is our first one, just a regular old customer. That's those two lines right there. And this one we can see is calling the overridden toString method that we created in our online customer class here. I believe that's everything that the exercise asked for. Let me see if there's anything else. Nope. Perfect. Are there any questions about what we did here before we move on to our next example? Okay, great. Our next and I think final topic really for the day is all about polymorphism. So we're going to do some more examples of inheritance, just get used to creating subclasses and things like that. This time we're going to talk about bank accounts. So I'm doing a little banking app, right? And we think of a general bank account. We think of, what does a bank account have? So there's a name of a person associated with that bank account, and there's a balance associated with that bank account, so an amount of money. If we think about, what are some operations that I expect all bank accounts to have in common? Can somebody tell me, some common operations you would expect to find in your bank account? What would you expect bank accounts to be able to do? Yeah. Check balance. All right, so some kind of a getter for the balance. We could do it this way, or I think you could also use the automatic way of creating getters and setters. I'll just do get balance right now. We may need to come back and do a different one later. We'll see. Anything else? Any other kinds of operations that you would do on your bank account? I can think of a couple. Yeah. Withdraw and deposit are the two big ones, right? So bank account's not super useful to me unless I can put money in and get money out. So those are probably the two biggest ones to take into account. This is going to be our base class. This is going to be our super class. So we're really not using inheritance here yet. But what I'm trying to do is think about what are the things that all accounts have in common. That stuff goes in my base class. So the kinds of operations that I expect all accounts to be able to do goes in my base class. The kinds of operations that are specific to certain types of bank accounts, we're going to take a look at two different types for the rest of the day today. We'll put in those individual subclasses. But just to kind of get us going with this basic bank account, I'm going to put in a method for deposits. I think for a deposit, a void is a good return type, but if somebody has a different argument for me, I'm open to hearing it. It's going to accept, some amount of money that I wish to deposit in here. And, the simplest version would be to just say the balance is equal to the amount. However, I could think, spelling again. I could think of some problems that could go wrong with this. Can anybody think of an issue where this would be a little weird or not what we want? What values can I plug in here? I could put in negative values here, and that would be a little weird, right? Depositing a negative amount is actually a withdrawal, and I don't think the banks really want me to do stuff like that. That doesn't really sound like the way banks like to operate. They're very strict, like things to go a certain way. We could check for that though, right? I could just say, if the amount is greater than 0, the amount I want to deposit is greater than 0, put it in. Otherwise, just ignore it. Don't touch it. Just leave it. Somebody screwed up. Not going to do it. Everybody with me? We got similar kind of thing to worry about for withdrawals. This one I think you could say, void, or if you wanted to, you could say double. Actually, I think the argument for void or double is kind of the same. Do I want to return what the new balance is? I don't think it's actually necessary. If I want to know what the balance is, I can always call get balance, right? I can always say, hey, tell me what the balance is. So that's why I think maybe void is better here instead of a double. But it's your class. If you like to, have it say what the new balance is once after every deposit and withdrawal, you can change that to a double and return that value. That is a decision that you can totally make. I'm going to proceed by creating this withdrawal, and I think we kind of have the same issue here where, if the amount is less than 0, I don't want to do the withdrawal. Right? I don't want to withdraw a negative amount. That feels weird. So I'm only going to withdraw amounts that are greater than 0. However, there's another situation that I think I need to pay attention to. Let's say I go down to the bank after work today and I say, I want to withdraw $1 million. I'm not doing that well, y'all. Right? I don't have that much money in my bank account. I certainly wish I did. But the bank's gonna be like, sorry, you don't have $1 million. That's not a thing you can do. I can't take out more money than I have. I don't want to allow that to happen, right? So we also need to check and make sure that the amount is greater than the balance. Make sure that the amount is greater than 0, but also make sure the amount is greater than the amount of money. I guess we could say equal to. Most banks don't like you to zero it out entirely. They would close the account if you did that. They usually like to have some minimum amount kept in the account. Yeah. I'm sorry. It would be less than. Yeah, my brain flipped it. Yeah, it would have to be less than or equal to. Yeah, so, make sure that you actually have enough money. Most accounts don't like you to zero it. If you wanted to, have a minimum, you could. Right? It has to be less than the balance minus 5. What's this though isn't great. This is an example of magic number. Not a huge fan of that. I'm just going to let it be. I'm going to let us zero out our bank accounts. I know that's not what a true bank would do, but this is our bank. We get to make the rules today. All right. So we want to withdraw a positive amount of money, and we actually have enough money to do it. Then we'll do the withdrawal. This stop balance is going to subtract out the amount. Everybody with me? Everybody cool? Awesome. Okay. Let's talk about then different types of bank accounts. This is just meant to be a general kind of all-purpose bank account. This is actually our base class. This is our base class. I want to talk about different types of bank accounts. You can see the first one's actually already here. The savings account. One of the, what makes a savings account a savings account? This really isn't as true as it used to be because the economy is the economy. But savings accounts give you interest, right? You get to collect interest on money that you save. That's sort of the incentive for having a savings account is you get to collect interest on it. The interest is like tiny. It's absolutely minuscule, so small as to not really be super worth it anymore. But that's still what makes a savings account a savings account. They still give you that money. I still get like 10 cents, every month on the balance of my bank account for interest. So that's what we're going to include. In order to do that, let's think about what this class is going to be able to need to do. It's going to have a name, right, and a balance. It's going to still need to be able to check the balance and make deposits and withdraw, right? It's going to have to be able to do all that stuff. In addition to all of that, it's also going to need to have some sort of an interest rate tied to it. And then it's going to need to be able to calculate that interest. How much interest are you owed? We'll keep the math very, very simple for today. I'm not a business guy. I'm sure there are business people in here who could talk all day about interest rates and things like that. That's not this kind of a class. We're going to keep it very simple. I'm going to go into my savings account, and I'm going to make, not public, an instance variable to represent the interest rate. Not all accounts have interest rates. So I don't think that this is an appropriate instance variable to put into the base class, because then it would imply that all accounts have interest rates associated with them, and that's not true. Savings accounts have interest rates associated. Money market accounts also have interest rates associated with them, right? But checking accounts, for example, you don't get interest on that. Usually, that's not a thing that happens. So think about carefully, right? Does it go in the base class? Is it useful to everything, or is it really just limited to some of the subclasses? That can help you decide where these types of things are supposed to go. The next thing I like to visit is the constructor. So we need to create a constructor for our savings account. And it's going to have to do, again, I know I've reviewed this before, but obviously this is one of the most important concepts that I hope you take away from today. We have to set all of the instance variables from the base class, and we have to set all the instance variables from the subclass as well. So I'll take in a string for the name, I'll take in a double for the balance, and I'll take in another double for the interest rate. We'll use the constructor of the superclass to do the name and the balance. And I forgot to do the same thing that I forgot to do last time, didn't I? I forgot to use the extends keyword here. All right, there we go. For the interest rate, we'll just say something like that. I think honestly we're just about done with this class. The only other thing that I can think of that I want to add, at least for the purposes of this example, is a way to compute how much interest is owed. And so in order to do that, we need a method, maybe public double compute interest. Or I guess there's some question in my mind as to how this method should work. Is this method going to compute the interest and add it into the balance? Or is it just going to tell me what the interest is and then I have to deposit it? It could go both ways, right? It could go both ways. And depending on which option you choose, that has an effect on return type. I actually think both options are valid, right? Having a method that tells me how much interest is earned and then I have to call deposit to put that money in the bank account, I think that's fine. Having a method that does both of those things at the same time, also think that's fine. I think they're both okay. I think they're both okay, and honestly, if you have a strong preference one way or the other, that is the best reason of all to do it that particular way, as far as I'm concerned. I'm going to keep this void for now and do compute interest, and I'm going to do all of it in one go. So I'm going to compute the interest and deposit it in all in one method. And so we'll do that first by doing a little bit of math. I need to say this dot balance times this dot interest rate, and probably set that to a value, right? Double interest owed is equal. Question? No? Did I miss a hand? Okay. But we have a problem. We have a problem to talk about. It's unhappy. You can see Eclipse is unhappy with me. We've seen this before. We saw this 2 weeks ago when we talked about objects. It says this dot balance is not visible. Now wait a second. Why wouldn't I be able to access this dot balance? It exists in the account class, and I am doing inheritance. However, this keyword right here is doing its job. Quite literally means you cannot access this outside of this file, period. I don't care if you're using inheritance. Still cannot access this variable outside of this class. Will not let you do it. So what's the solution? Anybody have an idea how we can get around this? Yeah. Use our accessor methods. Good. Use our accessor methods. Yeah, this is a time to use accessor methods. If you wanted to change the balance, right, this will tell me what the balance is. If I actually want to influence the balance, then I can use deposit and withdraw. That's what they're for, right? That's what they're for. So using these methods, using the accessors and the other methods that we have, we can manipulate the balance that way. It's not possible to access it like this with our current knowledge. I will say that if you take future computer science classes, there is another way to get around this restriction. Some of you maybe have seen this if you've done computer science before. We're actually not going to talk about that in this class. The The official answer in this class is to use getters and setters, call the other methods if you need to, but don't be surprised if you stumble across other solutions, especially if you move on to take like 332, the object-oriented programming class. We'll talk about this in a lot more detail. For now, we're gonna call super.getBalance here instead, because that will use the accessor to retrieve the balance and substitute it in the computation. And then once I know how much interest is owed, I can actually say super.deposit to put that money into the account, right? You can use the already existing methods. This is nice, yeah.
Why use super rather than this?
I actually, so the question is why use super instead of this? I think they both work. But to maybe answer your question in a little bit more detail, why use super instead of this? When I see the word super, it's a nice reminder to me that this method is coming from the base class. Whereas if I just see this by itself, I don't actually know that or not. I have to kind of go scroll through the code and see if that's true. Yeah. But they both work. They both get you there. Okay. And as far as this method goes, I think it's pretty good. But I want to use inheritance again. There's actually nothing saying that I can only use inheritance, one time. There are many different types of bank accounts in the world. In fact, I already said the other type of bank account that I want to create and work through with you. I want to create a checking account as well. So checking accounts don't do interest. But what checking accounts usually do allow us to do is overdraft. So they allow us to break that restriction about withdrawals that we talked about. I can actually go into the negative, right? A little bit, not infinite, right? They cut you off. They provide a limit. They provide an overdraft limit. If you try to withdraw, $50 beyond your balance, we'll let it go through, and we'll charge you a nice hefty fee, right? But we'll let it go through. We won't bounce your transaction. So, what does a checking account have that a basic account doesn't have? Or, what does a checking account have that a savings account doesn't have, right? You can't overdraft on a savings account. That's not what they're for. It's not what they're for. Checking account has a overdraft limit. This is usually a number in dollars. So this would be like $50. That's my overdraft limit. Lets me go $50 below my balance. If you wanted to, I don't think I'm going to do this, but if you really wanted to, you could also create an overdraft fee that gets, tacked onto the account as well every time you overdraft. But I'm going to keep it simple for today. So when I create my checking account using the checking account constructor, we still have the name and the balance, just like we did from our base class, which reminds me, I have to do my extends. I always forget this. Today I've been forgetful of the extension. It's okay. It's okay to forget things, honestly, as long as you know how to fix things when Eclipse gets mad, know how to interpret the messages and be like, oh, I forgot. I gotta go fix that. That's programming. That is perfectly acceptable. All right, so I know I need the name here. I know I need a balance here. And then my third parameter is going to be my limit, my overdraft limit. Where did you come from? Just like we did with our savings account, we'll use the constructor from the base class to handle the first two instance variables, and then we'll set the overdraft limit directly, like so. And for the checking account, we need to modify the behavior of specifically the withdrawal to take the overdraft into account. The question is, can I use this at all as, so what do I need to do? Can I just use this as is and then modify it a little bit, or do I need to just start over and write from scratch? Does anybody have any ideas? I think that this is pretty set in stone the way that this one works. It's only going to let us do it up to the amount that we have. If I want to change that, I really think I'm going to have to redo it from scratch. I have to start over from scratch. What's that called again? Overriding. So I need to override the withdrawal method in my checking account so that I can add in that overdraft behavior. I don't see another way to do it. So I'm going to override the method. It's not necessary to type the word override in here like I'm doing, but I still kind of like to do it just to remind myself, just as a little note to myself that, oh yeah, I overrode this method from the base class. It'll still work even if you don't. So if you leave that off, that's totally fine. But I'm going to make public void withdraw. I have to withdraw a certain amount. And it's going to look very similar to our existing withdrawal method, right? We're just going to have to factor in the overdraft amount here. So, I mean, as much as it kind of don't like just copy pasting this entire thing, it kind of makes sense because really the biggest difference is going to be to subtract out the overdraft limit. But you can see we have the same error that we had before. We know how to fix this though. We already ran into this. You know how to fix this? So we would say this dot get balance. But here's a problem. Here's a problem. I want to subtract this amount from here. I can't use super dot withdraw though, right? That's not going to be possible. That's not going to let me do it. Any other ideas how I can get around this restriction? This is a tricky one. It's a tricky one. I'm sorry? You're so close. Not get balance. Change one letter though. And we could have a set balance method. That takes in an amount and just says this is a little risky because this is not a checked withdrawal. We really want to use deposit and withdrawal when necessary. But in this case, we've determined a need for an accessor, right? This is kind of a review of what we talked about a couple weeks ago. I don't put in getters and setters automatically. I wait until I have a justified need for them. I feel like this has justified the need for a setter for the balance. I feel like I've justified the need for it because there's no way for me to pull this off without it. So that changes this statement to become this dot set balance to this dot get balance minus amount, and get rid of that extra semicolon. Did I spell it? Oh, I need to save. Save. There we go. So this setter was necessary. I don't really see how we can accommodate this with this overdraft withdrawal without it. It's not really hurting anything. I would definitely prefer if I could have used withdrawal and deposit here instead, but I couldn't. I really couldn't. So the setter was necessary, and I added it in. That's okay. That's programming. That is how programming works. I need this method. Okay, let me go add it in. All right. So I have created two subclasses from the same base class, right? Two subclasses from the same base class. I have this generic account class that provides basic functionality, the getters and setters for balance, as well as deposit and withdraw, those basic operations. I have the savings account class that does all of that stuff, right? Because of inheritance, it does all of that stuff. Plus, it has the ability to keep track of interest, compute the amount of interest that is owed. And then we have the checking account class that also does all of the basic stuff from the bank account. Plus, it has the ability to take into account overdrafts, which the other accounts don't have the ability to do. So again, I kind of want to reiterate this idea. What does inheritance allow us to do? It allows us to take stuff that is common to many different things and put it in one place. if I didn't have inheritance, what would this class look like? It would also need to have a deposit method, but it would look exactly the same as the one that's in the account class, right? It would be a duplicate version of that code. I don't like having code that is identical in two different places. Then they can become out of sync, right? It's much better to have one version of that code and use inheritance to refer back to it. That way we can reuse that code more effectively. The other thing that I want to talk to you about to kind of wrap up this concept of inheritance today, let's revisit this idea of polymorphism. I'm going to make a new class. Where do these accounts live? They live at a bank, right? They live at a bank. So if we think about it, what are the things that I would expect to have at a bank? A bank has well, it would have an array of accounts. Let's think about this for a second. An array of accounts, right? What kinds of things can I put into this array? I can put accounts, obviously. That's the type that is on the array itself. But I can also put anything that inherits from this base class, because the inheritance relationship says that a savings account is an account. A checking account is an account. So if I create one of those things, I can also add that to this array. This is actually an example of getting around that restriction, right, of having different types of things in an array. Well, using inheritance, you actually can have different types of things in the array as long as they all have the same base class. As long as they all inherit from the same thing, you can put those things all in the same array. Think about how useful this is, right? Let's say I need to make a deposit on a particular account. I fetch it out of the array and I make the deposit. It will automatically use the proper deposit method from the savings account class or the checking account class, depending on what it is. I don't have to know. I don't even have to know whether it's a savings account or a checking account to pull that off. Let's try and expand this example a little bit more by making a quick little constructor and adding a few methods and testing this out. The constructor, its role is to, initialize the variables for an array. That means creating a new array. So we have to specify a size here. This would be like the maximum amount of counts that we want to have at our bank, which is a little silly. In practice, I don't think there necessarily is a maximum amount of accounts you could have at a bank. We're actually going to see next week, I'm going to introduce a new data structure that would actually be a better choice here than an array, called a list. A list would be a better choice here than an array, in my opinion. But I'm not going to talk to you about lists until next week, so we're going to use arrays for now. Right? This is going to create a list of 10 accounts that we can use. And then, if I want to, I can have a method to add an account. This is kind of a similar idea. Notice the type that I used here. I used the type of the base class, but anything that inherits from that can also be used as a parameter here. So if I wanted to put in a checking account class, I could do that. If I wanted to put in a savings account class, I could do that. I don't know if I actually want to do this one. This is reminding me very much of adding a student to a course roster in assignment 7 right now. I think I'm actually going to go in a slightly different direction, in part because I can see that I am almost out of time. So just want to make sure I have time to make this one last point real quick. I think this bank example is great. I'm kind of abandoning it and going in a different direction, but I would encourage you to play around with that. It's great practice for inheritance. I'm going to speed things up a little bit by just kind of hard coding in some accounts down here. I'm going to create 3 bank accounts. I'm going to create one for the base class, and I'm going to create one for the savings, I'm going to create one for the checking, right? So this will be my account, and I don't know, I'll throw $100 in there. Checking account. 2 equals new checking account. This is still my checking account. I'll put $1,000 in this one just so it's a little bit different, and we'll have an overdraft limit of $50, meaning I can go, you know, $50 below if I want to. And then finally I'll make a savings account. For this one, it's my name followed by the balance. I'll just do $10 and then an interest rate, which, you know, for a savings account these days is probably something like that. It's like next to nothing. Technically exists. Okay, but watch what I can do. I can say accounts at position 0 is equal to my first account. And I can say accounts at position 1, helps if I spell properly, is equal to my second account. And I can say accounts at position 2 is equal to the third account. I put all 3 of these accounts into the same array. This account went into this array, the checking account went into this array, and the savings account also went into this array, and that's okay. That is polymorphism. That is the concept of polymorphism. Polymorphism says, if I have a checking account, I can put that into an array that just has the type of account, because a checking account is an account. The most technical, you know, succinct, concise version of polymorphism that I can think of is the ability to refer to an instance by either its subclass type or its base class type. That is polymorphism. I can refer to an instance of an object by the type of its subclass or by the type of its base class. How is this valuable? Consider, you know, banks would never really do this, all that. Well, actually, maybe they would. But let's say, for example, a bank wants to withdraw, you know, $10 from everybody's account. They're issuing a $10 fee to everybody at the bank. Right? This has never happened to me. I'd be a little angry if it did. But let's just say, for example, that happened. So, you know, I would say something like for account in accounts. I need a label for this. Use this for each loop. And then here I can say withdraw $10, but I want to make it very, very, very clear, you know, which version of withdraw is going to get used here. Well, the first one is just a regular old account, so it'll use the version from the account class, right? It'll use this withdrawal. The second account that I put in is a checking account, though. Even though I'm treating it as just a regular old account, it's going to know that it is in fact a checking account. And it will use the version of the withdrawal method that exists in the checking account class. It's always going to try to find the closest one that it can, right? So because the checking account class has this method overridden, it'll use that version. And I cannot understate enough how powerful that is, right? The ability to call this method from the checking account class without even knowing that the thing that I'm using is a checking account. I just know that it is a bank account, a generic bank account, right? The computer knows, and the computer will treat it appropriately. That is a kind of a trust issue for me as a programmer, that it's going to do that. But once you get used to that idea, it becomes a very powerful technique. Again, kind of think about what we would have to do in this bank class if I didn't have inheritance. Instead of one array that holds all of my accounts, I would need to have one array for the savings accounts, and one array for the checking accounts, and one array for the money market accounts, and one array for every single different type of bank account that I have at the bank. I mean, if that's something that you genuinely want, you can of course add that anyway, but the ability to have one array with all of the accounts in it is very, 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 very powerful tool Very, very powerful technique. And polymorphism is the concept that allows us to do that. So I really, really hope that makes sense. Really, really hope that's clear. My main method needed a void there. Does anybody have any questions about this? This is a tricky concept, so please. Yes?
Can you throw it out to the for loop at the bottom?
Absolutely, absolutely. This for loop probably needs, if A is not equal to null in here because I didn't fill the entire array. This is something that lists will help us with next week. Make this a little bit cleaner, but we don't have lists today. We have arrays, so have to be a little bit careful about that. Any other questions that I can answer before we wrap up class for the day? Okay. Please come to Studio. I know you have Studio drops, but this is a tricky concept. I really think you'll get a lot of benefit out of this week's Studio. I know you're busy, but please come to class if you can. Otherwise, have a good week. I'll see you hopefully in the labs on Wednesday and Thursday.